Namaste. Hope you are doing well. Today we'll solve the third question of ISI MSTAT 2021 PSB. And yes, the question expects you to know quite a bit about expectations. It has given you a random variable which can take any 5-digit number formed by the permutation of these digits with equal probability, because it's a randomly chosen number from that set. And there's another interesting variable, the random variable y, which is talking about the position of the digit from the right, position of the digit 4 from the right in that number. So if your 5-digit permuted number turns out to be this, because 4 is present at the second position from the right, first, second, third, fourth, fifth, these are the positions from the right. That's why it's taking the value 2. So this is the understanding of the setup. You have to find the expectations, you have to find the conditional expectations, and you have to talk about uncorrelation, whose formula again deals with covariance, which deals with expectations. So too many expectations, but it's interesting. Let's get started. Now, in order to find the expectation, we need to have some idea about the distribution, and maybe I gave it away in the way I was introducing the question. And yes, there is X following discrete uniform distribution. Because X can take any value from the set of permutations with equal probability, and there are total 5 factorial permutations of the digits 1, 2, 4, 6 and 7 possible. So the probability that X takes any value in this set of permutations is 1 by 5 factorial. Neat. Similarly for Y. Now, the thing about randomly choosing, when the question says randomly choosing, it means that nothing is more likely than the other. So it means that in this case, the digit 4 is as equally likely to be present over here in the set of numbers than here. Same with other positions. So, and each, forget this for a moment, and if the digit 4 is present in the first position, it's fixed, and the rest of the numbers can be distributed in any 4 numbers, they can be distributed in 4 factorial ways. Perhaps the question makers deliberately, it's a very sophisticatedly designed question. You'll see more about it as we progress. Too many 4s are popping up. So essentially, for fixing at the digit 4 at any position, there are 4 factorial ways to do it. And because the total is 5 factorial, this is going to be the probability that Y takes any digit in this, any position in this set, which is 1 by 5. Now, we have an idea about the distributions. Now we go for the expectation. And because it's discrete, the probability that each value takes is going to be the same 1 by 5 factorial. So finding the sum and then scaling it by 5 factorial will also do the job. And what's interesting about the sum is, so you have these 5 positions in a number. Once again, because it's a discrete uniform distribution over the set of permutations, say that digit 6 should be present in this position equal number of times when compared with this position, right? So it's going to be 4 factorial. Digit 6 is going to be present 4 factorial times over here, and 4 factorial times over here, so on and so forth. And not just digit 6, all digits, whatever position they are fixed in, there will be 4 factorial numbers from the total set of 5 factorial numbers of permutations of these that will have the digit. And using this, getting to the sum becomes very easy, because when you're looking at the unit place, the contribution that is coming from each of the digit will be 4 factorial times. And when you add it all up, you have something like this. Similarly for 100th place, 10th place, similarly for 100th place, 1000th place, and 10,000th place. Pretty neat. There is a not symmetric, but there's a structure to it, a neat structure. What's more interesting is that you can break this 20 into 5 times 4. You take the 5 out, keep the 4 inside, that 5 multiplies with that 4 factorial and becomes 5 factorial. And you can see where this is going. When you add it all up and then just scale it by 5 factorial, that's it. That's your expectation. 4, 4, 4, 4, 4. I told you too many 4s will come. As for why, we established that it's a discrete uniform distribution. So, and it's the points in that set of values it can take, they are equispaced, so it is going to be the middle point that is going to be the expectation. Okay, now the second question, conditional expectation. To get to it again, we need to connect to the conditional distribution, and we do it the old-fashioned way, the formula to get it. Now, when we are talking about this probability, we have to consider 2 events occurring simultaneously. First is that x is taking the small value x. That is going to happen with probability 1 by 5 factorial. And joined with that event is the event that in the number small x, y should be, and 4, the digit 4 should be at position y. What it means is, if you have, say, x equal to x and y equal to 1, this probability, it means that whatever your number x is, it has to have y, it has to have 4 at the first position from the right. So it has to be a number of this sort. So a number like 4, 6, 7, 2, 1 is acceptable, but a number like this is not. Hence the indicator function. And we get the distribution, conditional distribution. It's resonant with the distribution of x, and that gives us the idea to use the same methodology to compute the expectation as we did with x. The case with x was over taking values over a set that had 5 factorial elements, and the conditional distribution x equals to x given y, the conditional distribution, is going to take values from a set that has 4 factorial elements in total. Now, think about it. Because again, there is an element of, it's essentially a discrete uniform distribution only. So when we fix a digit, understanding it with a value for y is crucial. So if we fix the digit 4 at the first position from the right, in all of the 4 factorial numbers, that is going to be the contribution from the unit place. The other remaining 4 numbers, I don't know why this thing showed up. It vanished as well. It's some glitch. So in the other remaining 4 positions, the remaining 4 numbers can be arranged in the remaining ways. And in the remaining positions, each of the remaining 4 digits, 1, 2, 6, and 7, they are going to be present in an equispaced manner, which we can extrapolate from our previous exercise of computation of expectation of x. It's going to be 3 factorial. It means that the digit 6 here is going to pop up 3 factorial times in total of the numbers formed. And similarly for 7, 2, and 1. Now, the other thing to transcend beyond this is whatever value of y you condition it on, that's going to be the same. So if you had even something like this, wherein 4 is fixed in this position always in the 4 factorial numbers, even the remaining positions, which are 4 in total again, they can have the similar argument. And that's why the contribution from each position ends up becoming this jth position from the right. So once again, wherever the digit 4 is fixed in whatever position, that is going to be the contribution. But in all other positions, the way the question is structured, 1 plus 2 plus 6 plus 7 ends up to be 16. 4 times 4, you take the 4 out, combine it with 3 factorial, you get 4 factorial and 4 remains inside. Again, you see where this is going. This is the sum. The probability of taking any value is 4 factorial. You scale it by 4 factorial and that's your expectation. Neat. Now, the final part. X and Y are uncorrelated but not independent. Obviously, we have to use the information obtained from the first 2 parts of the question because that's how these questions are structured. And the second point to think about is what would be the easy way to show dependence, because not independent means dependent. So the first thing is you can notice that the correlation is going to be 0 if and only if when the covariance is going to be 0, and covariance has a formula with expectations, and we'll see shortly that there's a role that conditional expectation also plays. That's why looking at covariance is meaningful. And the easiest way in this case to show dependence is to show that there's one point of difference. There is one point where this probability is not matching this probability. And then that would mean that Y has a role to play. Y can influence X, and that's how you can show independence. Now, looking at the covariance, it's this. This is known. But here comes the trick. We have to use information that is already there, and that gives us the motivation to use the iterative property of expectation. This expectation can be written as this, and the motivation is the moment you do this, in the nested expectation, Y becomes a constant and it comes out like this. And then you have something that you already computed. And because that thing that you computed does not depend on the value of Y and is the same as expectation of X, this also comes out and these things cancel. So essentially expectation X given Y was 4, 4, 4, 4, and even expectation X was 4, 4, 4, 4. That's why things cancel. And to talk about the not being independent, it's quite intuitive actually, because in the beginning itself we noted X takes values, all values in the set of permutations equally with 1 by 5 factorial. But the thing is, the moment you condition a digit for the digit 4 to be in a particular position, it means all other possibilities where the digit was in other positions would be cancelled. So for instance, in this, because 4 has to be in this position and it's not there, that's why this value can never be taken. It's 0. So we have a point in which there is a difference in probabilities of the marginal and the conditional distribution, and it suffices to show that there's dependence. That's it. All the expectations are over now. And some ways to build your base is, you cannot expect this beautiful symmetry in every question, but thankfully, when there are questions that have this kind of symmetry, in this context, the symmetry was the question being designed in such a way that force come up. The sum is having a lot of force. The average of the digits, when you sum them up and divide them by the total, is 4. So this presence of symmetry can help you simplify the expectations. And it was because of this thing that getting the covariance to be 0 got very easy using this information. That's it. If you like this was helpful in any way, then the request is to think about actually how dependent you are on what you think is irrelevant, because we have a bias to think that we are not dependent on a lot of things, and we are actually dependent on a lot of things. So think about it. The feeling of humility is really helpful. Take care. Hare Krishna.